Hi, Anthony Carruthers, Better Lesson Master Teacher Project, and this is a Desmos demonstration that I do to wrap up this lesson on regular polygon areas and the ratio between those and the circumscribed circle areas. So to begin, we'll just launch the calculator. And before we start the graph, we'll actually need to change some of the graph settings. So I'm going to go over here to the graph settings menu. Once there, I want my x-axis to go from 0 up until 50 or so, and step value I'll do 10. And then for the y-axis I want to go again from 0, and I shouldn't need anything more than 2 since I know how this graph is going to turn out. Okay, on angle is very important that I need to be in degrees because the function that we created has angle measures in degrees. So now that that's done, I'm going to go ahead and put this in projector mode also, and then I can come back out to the graph. So to actually get the graph started, I'm going to need a table. After all, this is going to be a discrete function, so I want to graph discrete points. And I'm just going to change the labels. Instead of x1, I'm going to use n because that's the variable that we use. And then I want to put the function in, which is n times the sine of 360 over n. And all of that is divided by 2 pi. And for pi, I just type in pi. Okay, so we have that, and so we know that the practical domain starts at 3, so I'm going to put 3 here, and then I'm going to also have 4, and then hopefully Desmos will catch on if I just keep pressing enter or return, and it will keep updating. So as we can see, and actually let me just scoot this graph over to see it a little better. Okay, as we can see, as I keep adding more and more sides to the polygon, the ratio between the areas is getting closer and closer to 1. So we can go on and go on and go on and go on and go on. And as we can see, basically that's never going to go past 1. Some of the students will think, well, it looks like it actually gets onto 1, and I just explained that that's a limitation of the visual display. But even if we look closely at the dots, you can see that they're not actually, their center is not actually going through the 1. So they're just getting closer and closer to 1. And that's how we demonstrate that this function approaches 1 as n approaches infinity. And then it's just time to discuss why that's the case. Okay, once again, Anthony Carruthers, Better Lesson Master Teacher Project.